All right, so for this problem, this is problem 425. Basically, we have this boom, cage, and man, and we're interested in the moment that each weight produces about that point A. So we have I'm going to draw a free body diagram. So we have that point A is the one that we're interested in doing everything about. G1, that's the center of gravity for the boom. So that's the weight of the boom is at G1. And then, let's see, we have this basket. Looks different every time I draw it. We have the man in the basket. But let's see, so then G2 is the center of gravity for the basket. So that's the weight of or I'll call it cage because that's what I called it in the problem statement. And then for the man, his center of gravity is here at G3, and that's the weight of the man. And we're interested in those, and the moments about A, that each of those produce about A. So, let's see, so the moment due to the boom, the moment due to the boom about A is going to equal, and we're just going to stay with that sign convention. We're coming out of the screen as positive. Moment of the boom about A, and we can just do the perpendicular distance times that force, or we could do the perpendicular force times the distance. So let's do the perpendicular distance times the force due to the weight. So the perpendicular distance, we can just do 10 feet times the cosine of 75 degrees. So that's going to give us this distance right here. That's the perpendicular distance, and then times that force of the weight. So the boom was 1,500 pounds. And look at our free body diagram. If we take our fingers from A to G1, our hand, and then we do our fingers down in the direction of the force, that actually is going into the board. So that's going to create a negative moment about A. And now we can just multiply that out, and we get we get 3,882 pound-feet. And because it has that negative sign, it's actually in the clockwise direction. For the moment of the cage, about point A, and we'll again do the positive coming out of the screen. So the cage's center of gravity is at G2, so we just want that perpendicular distance. So what I'm going to do for this one is I'm going to get the perpendicular distance to here. So that would just be 10 plus 20, so that'd be 30 cosine of 75 degrees, and then add it to this 2.5 feet that was in the problem, and that'll give us that perpendicular distance to G2. So that's 30 cosine 75 degrees plus 2.5, that's feet, and then times that force, which is 200 pounds. And this one, we do the fingers from A up to G2, or the hand, and then our right hand, and then fingers down in the direction of the force, so that's also negative, or into the board. And so what we end up getting there is 30 cosine of 75, that's 7.76 plus 2.5, so that gives us that perpendicular distance, and then times 200. So we get 2,052, or 2,053 pound-feet, and this one's also clockwise. So then for the last one, is of the man. So for this one, the perpendicular distance is that 30 cosine 75 plus 2.5 plus that 1.75. And that gets us all the way to that perpendicular distance to G3. And then the man is 75 pounds. Or 175 pounds. So the moment of the man about A is going to equal, that's also in the negative direction. So if we do our fingers from A up to that G3, the force is down, so it goes into the board. It's a negative or into the screen. We get that 30 cosine 75 degrees plus 2.5 plus 1.75. So that gives us that perpendicular distance times his weight, which is 175 pounds. I guess that first one was feet. And we end up getting 12.01 for the distance times 175 pounds. We end up getting 2,103 pound-feet, and that's also clockwise. So that's problem 425.